video, I'm going to go over some of the basics of matrices and define addition, scaling, transposition, and multiplication operations for matrices. So what is a matrix? Well, it's just a rectangular set of values or numbers. So in this matrix A, I have on the right-hand side, we have a list of rows going down. So the A11 entry is row 1, column 1, A21, row 2, column 1. So these are the rows going down on the side, and then across the top, we identify these by columns. So in this matrix A, we have an M rows by N matrix, N columns. So the last entry in the bottom right is the AMN entry. So we identify it by these two numbers put in as a subscript. And typically we're dealing with elements with entries as real numbers, but not always. So these are used to represent things like linear spaces and used in linear algebra vector math or matrix math. And it underpins many concepts in data science and machine learning. So we use matrices and matrix math in developing things like least squares and principal component analysis or PCA, and very important operation called singular value decomposition, which I won't get into in this video. But it can be also used for more generalized representations. So we can use a matrix of values, this rectangular set of values, to represent connections between people, as in a social graph, links to and from websites, as in their inbound and outbound links, whether one website connects to another or the other website connects back to it. So we can represent these things in matrix form. Now let's look at some operations we can carry out with matrices. So we can add, scale, and transpose matrices. So adding matrices, they have to be compatible component-wise, so they have to have the same dimensions. So if you look on the right-hand side, we have addition, we have the entries 2 by 2 matrices. So we're adding two 2 by 2 matrices. So the first one, there's entries 1, 2, 3, 4. The second one, 5, 6, 7, 8 are the individual entries. So you add them component-wise. So the first entry in the row column 1, 1, in the first matrix gets added to the corresponding one in the second matrix. And so we get 1 plus 5. So the entries, and you can look at the corresponding additions from entry to entry, and we see we get 6, 8, 10, 12, adding 1 plus 5, 2 plus 6, 3 plus 7, and 4 plus 8 from the corresponding matrices. We can scale a matrix by a scalar, so we have an individual number value that we scale the entire matrix, so it scales each entry in the matrix. So we